Okay, so good afternoon, everybody. So I explained flip-flops, okay? So I explained before flip-flops. So flip-flops are logic circuit. It's a logic circuit. We created them using AND, OR gates, AND gates, NOR gates. So it's logic circuit, okay? And these flip-flops are actually used for one of two things. In logic circuits, we use flip-flops for one of two things. Either as a storage unit to store one bit. So you can use it as a storage unit to store one bit. Is that okay? You can use it this way. Or flip-flops are actually essential components for any sequential circuit. Okay? As I told you before, in sequential circuit, you must have flip-flops. Okay? You may or may not have combinational circuits on top of the flip-flop, but flip-flops is a must. Okay? So this is what I explained to you before. I can use flip-flops as a storage for only one bit, and then I can say in most of the cases we need to store my data is more than one bit. You got what I'm saying? So if I get a character, if I ask the user, please give me a character. Okay, so the user is gonna give me, for example, letter M or letter N, whatever the character is. Okay, and then this character is actually converted to ASCII code, and this ASCII code is actually 8 bits. So it's one piece of data. I'm very careful here. It's one piece of data, 8 bits. So every bit doesn't have any meaning. 4-bit doesn't have any meaning. It's just one piece, 8 bits. Is that okay? And that is why in any logic circuits, I need a storage unit that is bigger than 1 bit to store the data, right? And that is what we call registers. So registers are storage units that can store n bits. And based on your system, this, as you will see in the coming courses, sometimes registers are 8 bits. Usually we use 8 bits or 16 bits or multiple of 8 bits, usually. But this is something you can design. If you want to make it 7-bit, yeah, you can make it. If you want to make 3 bits, you can. This is something you can design, okay? And as I explained last time, inside this register is actually you have n flip-flop, where every flip-flop is storing 1 bit. You got what I'm saying? This is the part can confuse you. If I have n flip-flop, so can I read only one flip-flop? It doesn't have a meaning because I'm repeating several times. This one piece of information. You got what I'm saying? So it doesn't have a meaning to read 1 bit. I need to read everything. I need to read the byte or the whole information. Anyway, so that is why I explained last time how we can create register of n bits so that I can store a number here in binary, 1010 whatever, okay? And then you can exchange it if you want, okay? And I give you very quick idea about how they are useful in any digital logic circuit. If you have a big system, how they are useful. As I told you before, if you have, they are very useful. So for example, if I have an adder here, this adder needs input here, for example, 4 bits, and need another input here for 4 bits, okay? So usually these inputs are coming from registers. So the number here is gonna come from a register, okay? Also, the data in the register, usually they come from memory or they come from the user. You ask the user, please give me a number. You take a number from the user. I store them in registers. You got what I'm saying? Or I have numbers stored in memory. You got what I'm saying? For example, when you do something like y equal, like for example, x plus 2, an operation like this one, keep in mind everything in any program, in any programming language, every instruction you write has to be translated to a machine code because it has to be executed by the machine. everything you learned before in Java, in Python, whatever, doesn't matter what language is that. They have to be converted to assembly language, and then from assembly to machine code. So everything has to be done by the hardware. So if I want to do something like that, like what you did before, so what we can do, or practically actually what you do, this number 2 has to be stored here in one register. X, if X is a memory location called X, so I need to get this number, I have to put it here. I'm talking about how an instruction like this one, we use it in all programming languages, how we can do it by the hardware we explained in this course, okay? For sure, this is out of the scope of this course. In this course, I teach the main components we use, but it's not the purpose of this course to teach how we create big system, because this will be in common courses. But I just want to give you some idea how this can be used, okay? So what happens here, if X is a memory location, so we need to get this number, we need to store it here. Once we have the two numbers here, I'm gonna give, or the control unit, there is a control unit, is gonna give the so to execute this instruction, the control unit, number 1, like, look here, that's why you can see timing, there is a timing, that's why you have a clock, you got what I'm saying? So in the first clock, I'm gonna fill, for example, I'm gonna put 2 here, I'm gonna put the value of X, read it from the memory, put it here. This is step number 1. Once this is done, okay, I'm gonna give the order to the other, okay, to do the addition. Once the other is done, so for example here, the other is gonna store the result in another register here, okay? So now I have the result here. So because Y equal X plus 2, and X plus 2 is already here in this register, so after that, the control unit has to do some operation to store this register in a memory location called Y. You got what I'm saying? So anyway, I don't want to, it's okay if you don't fully understand it, but what you should understand here is, number 1, how registers are important. This number 1. Number 2, you should understand when you create a big system, why you need a clock here, because we have timing, we have to do operations. So in the first clock, I'm gonna do a small task. In order to execute this instruction in 1 clock, I'm gonna do small task. Like for example, store 2 here in the first clock. In second clock, I'm gonna do another task. For example, get some from the memory, put it here. In next clock, okay. So the timing, I can't tell the other to add before putting the numbers here. Makes sense, right? So after that, once I get the result here, I need to do another operation. That's why we do it using clock. To make sure timing, okay? Anyway, so that's why last time I started to explain registers, and I give you here a very simple example. This is what we call, this, we have a register here. This register is 4 bits, that's why you have here 4 you can, for sure, you can do it using any type, okay? But here maybe it's easy to do D flip-flop. So you can have, this is 1 number, 4-bit number, 1 number. This number, every bit is stored here in 1 flip-flop, as you see here, okay? And all of them are connected to the same clock, as you see here. Also, all of them connected to a reset, just in case if I want to store 0. So if I want to initialize this register with 0, I can just put 0 here in this input. And then you can see here, we have here input here, okay? So what if I want to change the number I have here? All what you have to do, just put the new number here, like 1101, any number you want to store, just put it here. And then automatically at the first clock when it comes, this number is gonna move to here. Is that okay? This is what we call parallel loading, because there is another way to load it, okay? So here I'm talking about parallel loading. So parallel loading means this is a register. This register is storing some number like 1111, for example, any number. And now at the input here, I want to change this number to something else. I can put here, for example, 1001. Okay. When the clock comes, so this number here is gonna come here immediately. It's gonna replace. Many students asking me, what about the old number? It is gone. It's gone because you overwrite it. It's gone. Okay. That's what to call parallel. You can tell from the English name. Parallel because you input all the bits here, I input it at the same time. Okay. We have another way. So here, The opposite of parallel is actually serial. And serial means you input bit by bit. So here, listen to me. You should understand what is the difference between parallel and what's the difference between serial. Parallel means this is a number I want to store it here. So here I just put the number here, and I need only one clock. One clock, so this number is gonna come to here. I am done. There is another way, we call it serial. So in case of a serial, what happens is that, look how it happens, how it works. For example, if I have a register this way, this register, for example, is storing anything, like, for example, 0, 0, 0, anything. And then we have here what we call serial input. And this is the number I want to store it here, 1101, any number here. Is that okay? So in case of serial, so I'm going to store it bit by bit, serial. Okay, so what happens here, after one clock, these bits are shifted to the right after one clock. So here, if there is one clock here, so after one clock, this one is gonna enter here, and every bit is shifted to the right one step. So this bit is gonna come here, this bit is gonna come here, this bit is gonna come here, and this one is lost. So at every clock, we input one bit and we lose one bit. So we input one bit from here, and then all of them are shifted, the last one is lost. Okay. So that means after one clock, it's gonna become 1, and then this one is gonna come here, as I told you, and then this 0 is gonna be shifted, this 0 is gonna be shifted, this 0 is shifted, and then this one is gone. So every bit is gonna be shifted one position to the right. That's why I'm calling it shift right to your right hand. Okay. After a second clock, now this bit is gonna input here. Second clock. So, and everyone is going to be shifted. So now it's 1, 0, 0. This one is gone. Okay. And then I'm going to have here 1. Another clock, I'm going to input this 0. So every clock you input one bit. Okay. So it becomes 0, 1, 1, 0. And then after another clock, I'm going to input this one here. Okay. So it becomes 1, 0, 1, 1. So now I was able to store the number serially. Should understand what is different between serial and parallel. Parallel means only one clock, all the bits in one clock at the same time. Serial means every time or every one clock, you are going to input bit by bit, one by one. So if this register is 4 bits, that means I need 4 clocks, because every clock I'm going to input one bit. So I'm going to input this number here after 4 clocks. That's what we call serial. So you should understand what serial means, what parallel means. Any questions? But someone can ask me, but wait a second. Parallel is much faster. That's true, because I need only one clock. But here, I need n clocks. Yes, because n clocks, n is the number of bits in the register. So if the register has 16 bits, I need 16 clocks. That's true. That's why this one is slow. That's true. Okay, so if this one, it looks like a bad idea. No, it's not a bad idea. I'm going to tell you why. Simply because what happens is, before I move forward, I want to make sure you understand what is the difference between parallel and serial loading of a register. Okay. Now, no, this is a very important idea. It is used in many systems, practical systems. Okay, I'm going to tell you why for several reasons. Okay, I'm going to tell you why. So what happens is that, look here, guys. I want to make communication between this guy here. I want to connect this guy to this guy here, okay, to communicate. And for example, I want to send something like 4 bits, something like that, 4 bits, okay? To do that, I have 2 options. I can send the 2 bits parallel, but in this case, I have to connect 4 wires here, 4 wires. And then 1101, and then all what I need, only 1 clock. Once you have 1 clock, so this guy is going to receive 1101 immediately. That's what I call parallel. Okay, now the other way I can do it is using only one wire, and then I'm going to send this number here. I'm going to send it serially. That means after 1 clock, I'm going to transmit bit 1. which is this bit. Second clock, I'm going to transmit this bit here. This clock here, I'm going to transmit this bit, and then another clock. So I need four clocks. Okay. So that's why we have serial communication, we have parallel communication. Is that okay? So for sure, this one is faster because I need only one clock, okay, to transmit everything at once. But here, this one is slow because I need every time we transmit only one bit. You got what I'm saying? So this is bad, right? No, it's not bad because this one is widely used for two reasons, and maybe other reasons, but at least what I can tell you here, number one, it's very cheap because you need to connect only one wire, especially if these two guys are very far from each other. Is that okay? But it is slow. That's okay, but maybe the speed, it depends on the application. Maybe it is slow, but the speed should be okay for your application. You understand what I'm saying? Anyway, there are two ways. I can't say we use both of them. Both of them are okay. We use both of them, but you should, again, I'm giving you an example to still understand the difference between parallel and serial. Okay, so in this case, what happens is that here you are going to receive the data serial. So here you are going to receive the data parallel. So here, if I have a register here, I can do here parallel loading. So the data I receive, I can just put it parallel loading. I can load it parallel to the register. But here, because I'm receiving the data serial, so what I have to do here, I have to do serial loading. So I have to input the data here serial. Look what I'm saying. So again, any questions here? So conclusion before I finish it. If I have a register and I want to store the data in the register, two ways. One way, parallel, and that's what I already explained. So I already explained this one. What I didn't explain yet, and that's what I'm going to explain now, is actually how can you do it serial, input bit by bit. Okay. That is why we have another type of register. We call it shift register. Shift registers. Okay. It is a register. What it means? It means it's still register. It can store any bits. That's true. But on top of that, it is shift. What shift means? Yeah, that's what I have just explained here. Shift means if you have a number here, for example, a number something like that, and then I can shift. For example, I want to input 0 here. I can shift bit by bit. So after one clock, every bit is shifted. So this is here, look here, guys. This is bit number 0, bit number 1, number 2, number 3. So bit number 3 is going to become bit number 2, shifted one position. Bit number 2 is going to become at number 1. Bit number 1 is going to become at number 0. Sorry. So and the first one is lost. Okay. And the newcomer here, the new bit here that's coming is going to come here. So yeah, so what you see here, what I did, number 1, at every clock, I insert one bit, one new bit. At every clock, I lose one bit. At every clock, every bit is shifted position by one position. Is that okay? And if I do this way, that's what I call shift right, because you shift it to the right. Is that okay? We can do it the other way as well. We can shift left. How? Very easy. So it's the same thing, but here, so it's going to become, for example, if you have something like that, so the input, they are going to be shifted this way. Okay? So that's what we call shift left. So what happens here, for example, if I input 0 here, for example, so this bit here, bit at position number 0, it becomes at position number 1. Position number 1 becomes at position number 2. Position number 2 becomes at position number 3, and this one is lost, and the new one is going to enter from here. That's what we call shift toward the left. Any questions? You understand what I mean by shift here? Okay. Now, show me the circuit that can be used to do this shift. Okay. Very easy. Very, very easy. Look here. That's it. This one here. This circuit is for shift right. Okay. Look how it works. Here, we have the serial input here. Is that okay? So what happens is that, so very, very easy, very interesting, very easy. We have, because this is 4-bit register, we have 4 flip-flops. Is that okay? And the output of every flip-flop is connected to the input of the next one. Output here connected to the input, output here connected to the input. Is that okay? Look what happens. What happens here? What happens when there is a clock? When there is a clock, A3 here is gonna come to here, because this is how a flip-flop works. The input of the flip-flop. So this one becomes A3, and A2 comes to here. So you can see every bit shifted by one. So this one come here, stored here. This one at the input here is gonna be stored here. This one is gonna be stored here, and the first one is gone, and this one is gonna come to here. You see it? So here, that's why I have here. So that's what I'm showing you. In the very beginning, assume it is 0, 0, 0. Assume the serial input is 1. So after 1 clock, this one come here, this one come here, and then this bit shifted 1 step to the right, shifted 1 step, shifted 1 step, and the first one is gone. I lose this one. Okay. And by the way, we take the output from, and then we take here, we have something we call serial output. Serial output, which is actually the first bit we have here, A0. We call it serial output. Okay. So again, if you have another clock, as you see here, so this one is going to be shift everything to the right. So everything is going to be shifted to the right. Okay. We always lose the first bit. Okay. And this bit is going to come here. This bit come here. This bit come here, and the new one come here. Okay. Is that okay? Shift left. Is that clear? Very easy, right? This circuit can do that. Let me ask you a question, because this will be related to the final exam. So here I give you a circuit for four bits. Is it difficult in exam if I ask you to draw a shift register circuit for 3 bits, for example, or 5 bits or 6 bits? No, it's not difficult. You just add here more bits, whatever, add more flip-flops here. You got what I'm saying? You can add more flip-flops. That's it. If you want to make it 3, I can just remove this one. That's it. Okay. Okay. Let me ask another question. Is that difficult? I give you here. I explain shift right. Is that difficult to make shift left? No. So all what I'm going to do here is, look here. This one becomes serial input. Okay, this one is the serial input because I'm going to input. D is here. This one is D. This one is Q. 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 And then this one becomes serial output. That's it. So that every time, what happens here, you move from D to Q, from D to Q, D to Q, D to Q. That's it. So it's almost the same way, but I'm going to input from here. Any questions? One more thing here about this circuit. So this circuit can be used like serial to a serial in parallel output converter. Okay, what this means? I'm going to tell you what it means. If you have a serial data here, for example, serial data 1101, serial data coming after 4 clocks, this one becomes here 1101. So I can take it parallel. So it's like you were able to make conversion from serial to parallel. So now I can take the data parallel. You got what I'm saying? Again, if you have data something like that 1101, after 4 clocks, you are going to see the data here 1101, and now you have the data parallel. You can use it parallel. Okay, so I can do serial to parallel conversion. Okay. Okay. One of the things also I want to explain here is I can say. So hopefully you understand what I mean by, because this is used it's widely used in digital system. Please, when you go to other classes, no one will explain. They should not explain. You should know from this course what shift right means, what shift left means, and how the hardware can do it. Is that okay? So we have something like, I can say it's just a special case of shift. We call it rotate. So what happens here in rotate, what is the difference between rotate and shift? Very simple. Here in shift, I'm going to input a new bit here. So new bit is every clock, I'm going to input a new bit, insert it or input new bit. Okay. So in rotate, you can tell from the English name, rotate. It's very simple. That's why I'm saying it's very easy. So what I'm going to do, I'm going to connect the output here to the input here. and no input, no inputs coming. So the same circuit, but the output here is connected to the input here. Can anybody guess what this should do? Number one, I'm not going to input new bits. Number two, I'm not going to lose any bits, but I'm going to just rotate them. So after 1 clock, this bit is going to come to here. And this bit is going to come to it. So still we shift. But the first one, he's going to input here. Okay? That means after 4 clocks, I'm going to get the same number again because all the bits are shifted. But anyway, rotated. So, or circulated. So I explain the concept here. So as you see here, okay, here, if I do here, here this way, so I rotate this way, okay. By the way, this one is called, still we have rotate left and rotate right as well, depending on what kind of shift you are doing. Here in this rotate, I shift left. That's why this one is called rotate. I'm sorry. This is towards your right hand. So if you look here, don't be confused. You shift towards your right hand. That's why this one is called rotate right. If you shift this way, it's called to rotate left. Okay. So look how it works. Look at the example here. So after 1 clock, this bit is gonna come back to here. We don't input new bits. Very clear. So this one becomes here, and then every bit is shifted 1 step to the right. So it becomes this way. So this one come here, this one come here. This one come here, this one circulate this way, okay? After another shift, what happens, this bit is gonna come to here. So now this is the new number is here. After 1 shift, this bit is gonna input here. So this is the new one here, okay? So you can see after 4 shifts, I'm gonna get the same number originally here. You see the difference between shift and rotate? It's almost the same, but there is a small difference. In shift, we input new bits and we lose bits. In rotate, no, just I rotate them. What I'm saying? It looks, why you do that? Again, this in some application, we need something like that. Okay, we use it. So here I'm explaining rotate right. Can you make rotate left? It's exactly the same thing. Okay, but here it has to be Q here. Okay, so it has to be because this one is this way, the other one has to be this way. Okay, so this one here has to be Q, and this one has to be D. Q, replace Q with D, okay? Think about it. Any questions? Okay, I think that's enough for today. Hopefully, so now let me tell you what I explained, and hopefully you understand. Based on what I explained, you should understand number 1, what is register, okay? And what you should understand, how can we load register in a parallel way? And you have a circuit for that. How we can load register using serial way. You should understand what we mean by serial, shift left, shift right, rotate left, rotate right. You should understand of this operation. Not only understand the operations, but also how hardware can do it. You get what I'm saying? And by the way, when you go to 3130, you are going to learn assembly. In assembly, every instruction you have is going to done by hardware circuit. That is why you will see, I used to teach 3130. That's why you will see in assembly, we have an instruction for shift because it has a circuit like this one to do shift. We have an instruction for rotate. You get what I'm saying? And so on. Okay. Anyway. Okay.